Hello and welcome to the 10th and final week of the OpShin Pioneer program. So for this last week, we again take inspiration from the Plutus Pioneer program, where in their last week, basically the lectures were about, after having the entire program in Plutus, like what are some of the alternative ways to develop smart contracts on Cardano. And they cover different languages, such as, among others, also OpShin, but then also Plu.ts, the TypeScript version, and also Icon, which is like a language of its own. And here for the OpShin Pioneer program, we want to use this last week to kind of do the opposite thing. So now that we've done everything in this OpShin alternative smart contract language, we want to just briefly go back and also kind of give a very quick introduction to Plutus, and then maybe also talk a bit about what are the advantages and disadvantages of using either language. So here on these two slides is kind of a reminder of the on-chain compilation pipeline at the top in the OpShin case and at the bottom in the Plutus way. So in the end, in both cases, the end result needs to be this UPLC code. So this is kind of the machine language of the Cardano blockchain. So the thing that the language like expressed in binary that is actually then being run by the nodes to validate. And of course, this is not human readable at all. So we need some higher level languages to compile down to this thing. And then in the OpShin case, there's one intermediate language, which is this so-called Pluto Python, which is based on Pluto, which is kind of the human readable version of UPLC. And this is just a Python kind of implementation of this Pluto. And this is the intermediate step that OpShin gets kind of compiled down to. Okay, and OpShin, we have seen many examples by now. Now in the Plutus case, the pipeline is slightly more complicated because there are like two more intermediate languages. So the top level is this so-called Plutus GX, and this is actually a subset of Haskell, actually similar to how OpShin is a subset of Python. So while Python is what is called an imperative language, Haskell is a so-called functional language, which is like kind of a different programming paradigm. And this Plutus DX is a subset of that. And then when we compile it, the next step in the pipeline is this so-called GHC core. And this is just because it's also part of the Haskell pipeline to first compile down to this thing. And then because we're using Plutus, there's kind of this so-called Plutus core, which is an extension that is kind of designed to be close to this GHC core, which is the classical Haskell version. And then in the final two steps before we go to the UPLC code, there's also, so this one is untyped, but then there's the previous step, a typed version that the compiler uses to do a certain type checking of the program. So yeah, at the end of the day, we don't really see this as a user, right? We just hit the compile command. But yeah, still it's good to know that there are several intermediate steps in the compilation. So next, to see a bit more the Plutus language, I just want to give kind of a side-by-side comparison to a contract that we have seen earlier in week 3 in the program. And so this was this kind of vesting example, right? So if you recall, it's a very simple contract where someone can lock funds in a UTXO at the validator address, together with a datum that contains a beneficiary and a deadline, and then basically the funds can be unlocked only by this specified beneficiary and only after the deadline has passed. So we had this validator here with the datum defined as above that has no redeemer because there's only one action to unlock it. And basically it just does these two checks. So the first one makes sure that it has been signed by the beneficiary that is written in this datum, just by checking that it's like in the TX info signatories of the context. And the second check is just that the deadline has been reached, which we do like using these functions from the OpShin ledger interval package. Now, if we go over to the Plutus side, so this is really an exact clone of this contract written in Plutus. And yeah, if we in the end, I think in this example, it's really mostly like different syntax. Let's say there's really not much else that's different in terms of how the program is written. So first of all, these vesting params that we had here in this class, in Haskell, the equivalent thing is this kind of data type that you construct out of these two fields, the beneficiary and deadline. And yeah, you see there's just slightly different syntax for kind of giving the types and so on. Then a similar thing for the validator itself. So it's really the same thing, right? We have some kind of a function here that has 3 parameters and a return type. And it's just a different way of writing functions here. So we give the name of the arguments here. So this datum, we don't have a redeemer, so we can use this kind of non thing, which is empty brackets. And the context, we call it ctx here. And then we again do these 2 checks. And yeah, in Haskell, the way to write the function is just giving the name and then giving all the arguments separated by a space. And yeah, just as in the OpShin case, we basically check that the beneficiary has signed and that the deadline has been reached. And otherwise, we use this trace if false function. So if this expression happens to be false, then we throw this error basically in the trace. And we combine them both using an AND. And then this whole expression together is a Boolean expression, so it matches kind of the return type of this function. And then kind of these helper functions, we in Haskell, the way to define them, if they're only used within the scope of this validator, is using this where expression. And in the first one, we just define kind of we take the info out of the script context. And then we have these 2 functions, signed by beneficiary and deadline reached. And they use like this, in this case, we use something that has been defined in this certain package here that just checks that the beneficiary has, the beneficiary that we get out of the datum is present in the signatures in this TX info field here. And then similarly for the deadline reached function, we use kind of these contains and from and so on that are defined here in this ledger API and ledger interval packages. And while there are these many similarities between the 2 codes here, you might still find maybe that there's some interesting like special things in the Haskell code. And one of the things that might catch your attention is kind of this weird expression here. So what we do here is that basically we compile the validator And these special brackets here is something in Haskell that is called template Haskell quotation. And what it tells the compiler is basically that here we don't want to evaluate the expression inside, but we want to kind of capture the code and pass it to the outer function. And in this case, the compile function is another function written in Haskell, right? So the Plutus compiler itself is a Haskell function. And yeah, we want to pass it this thing that we defined, the vesting validator, not as an evaluated expression, but really as the code itself. And related to that is also the reason that we need this inlineable everywhere, because usually the Haskell compiler might, if functions are not inlined, might already compile them when evaluating, and so in that case the compiler wouldn't get to see the whole function definition. And then lastly, you see also that somehow we cannot directly pass this vesting validator to the compile function, but we first define an extra wrapped vesting validator here, and then we turn the vesting validator that has the types here into a version that is this wrapped one, which just has the built-in data. It's kind of the untyped version of it. And the reason for that is that in the end, the on-chain code is really untyped. So the script context and the datum and redeemer are kind of passed in untyped way as kind of the raw data. But when we write the code, we still want to kind of make use of Haskell's typing, type checks, and these kind of features. And so we write a typed version first and then turn it into this untyped version that we then compile. So to wrap this up, I just want to maybe give a quick kind of sort of opinion on maybe what are the advantages and disadvantages of either language, Bluetooth or OpShin. So that maybe also can help you decide what is the best choice for your project. So I would say for Bluetooth, some of the advantages are that it's really kind of mature and battle-tested language. So it's the original implementation made by IOHK, and it has been used in many Cardano protocols. And yeah, there's many examples you can find online, audits been done, and so on. And moreover, Haskell is kind of known for its strong type system. So you really get the strong compile time guarantees about the types that might prevent maybe some of the bugs in your smart contract. But then on the more negative side, I would say disadvantage is definitely that, yeah, Bluetooth is a subset of Haskell, as we said, and while you might not need to know entire kind of stack of features of Haskell, definitely it has a steeper learning curve, I would say, than OpShin. And also, since many people already know Python very well, it might feel more natural. Then also, when compiling a Bluetooth contract, you might get some errors that are not very easy to read. So in that case, debugging can be a bit painful sometimes, I would say. And also the toolchain, so to compile Haskell code, so it's based on this Cabal and Nix sort of package managers, and yeah, this is sometimes quite a process to get everything installed. And OpShin, on the other hand, as we saw throughout the program, offers quite an easy onboarding experience. So it's very quickly installed, just as any other Python package, which many have done before. And the language itself is very familiar to anyone who's written some Python code. And even to those who haven't, it seems like it can be quickly learned. I think this allows you to, when developing smart contracts, to really iterate quickly and test different versions. And also because the language is sort of simpler in that sense, I would say for some contracts it really avoids some unnecessary abstraction overhead that might exist in the Haskell version, and really creates more slim contracts that might also even be smaller in the end in terms of the size they take on chain, and then also save some transaction fees. And with that, I would like to wrap up this last week of the OpShin Pioneer program. So thanks a lot for joining along. I hope you had a good experience learning OpShin and that you can write many interesting contracts in the future. Thanks, and see you.